Hello all, welcome to Vishnu's lectures. In today's concept, we are going to discuss about what is number systems and types of number systems. So actually, we have four types of number systems are there. They are binary, decimal, octal, and hexadecimal. So first we'll discuss about decimal number system. So decimal number system having base 10 and it uses 10 digits. What are the 10 digits? 0 to 9, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in decimal number system, we will use total 10 digits. And most commonly used in daily life means whatever the numbers you are taking, all the natural numbers are by default treated as decimal numbers. If I'm telling 5, what type of number the 5 is means it belongs to decimal. Okay, just like example, we'll see the example here. 345 to the base 10. So this 345 is treated as decimal number. What is the positional values? How to calculate this? So start with 0. So what is the last digits? Means what is the digit at ones place is 5. So you can write like 5 into 10 power 0. You have to use 10 to every number because this is a decimal number. Base is 10. So 5 into 10 power 0 plus 4 into 10 power 1 plus 3 into 10 square. Like this you have to calculate. If you calculate this, you will get this number 345. And the format specifiers used for decimal number systems are percentage %D. Very important point. For decimal number, the format specifier is percentage %D. Okay. Next, this is one number system. First one is decimal number system. Next, we'll discuss next one. Binary number system. The binary number system base is 2. Uses only 2 digits. In binary number system, it uses only 2 digits. 2 digits. That is 0 and 1. Okay. Next, used internally by computers and digital electronics. You know already the mission language is zeros and ones. So used internally by computers. And example, how to represent binary means 1000 1011, but base 2. This is treated as binary number. Okay. How to calculate this 1011? Base is 2. So at ones place, what is the number 1? So you have to write like this. 1 into 2 power 0 plus 1 into 2 power 1 plus 0. Next, this one 0 into 2 power 2 plus 1 into 2 power 3. Like that, you have to write the binary. Getting my point? If you calculate this, you will get this. And what is the format specifier used for binary number means percentage %B. Getting my point? And we'll discuss next one. Octal number systems. For the octal number system, base is 8. It uses 8 digits 0 to 7. Earlier it is used in computer systems also. Next, how to represent this? 725 to the base 8. How to calculate this? Same. At ones place 5 is there. At tens place 2 is there. At 100 place 7 is there. How to calculate this? Use every time 8 for calculation because the base is 8 for octal number. So how to calculate this? 5 into 8 power 0 plus 2 into 8 power 1 plus 7 into 8 power 2. And the format specifier used for octal number systems are percentage %O. And very important point, in octal number system, this is very important point. In octal number system, each digit represents 3 bits. In octal number system, each digit represents 3 bits. While you are writing programming, one more important point I'm telling here. Whenever you are writing programming, how to write octal numbers means you have to use 0, 0, 21. Then only it is treated as octal 21. If I write 0, 32, then this is treated as octal 32. In case if I write directly 21, then this is treated as decimal 21 by default. If I write directly 32, then it is treated as decimal 32. Getting my point? So this is the octal representation. Whenever you are writing, if you want to write octal numbers, then you have to write 0. If I write 0, 1, 2, 3, 4, then this is treated as octal 1, 2, 3, 4. Okay, this is octal representation. Next, hexadecimal number system. So in hexadecimal number system, for hexadecimal number system, the base is 16 and uses 16 symbols total from 0 to 9 and A to F. Means if you are using A, it means that 10. You cannot use directly 10. If you want to use 10, then you can use A. A means 10, B means 11, C 12, D 13, E 14 and F 15. Similarly, how to represent like this? 2F to the base 16. Here 2F is a hexadecimal number. And calculation, same. F means here 15. So you have to write 15 into 16 power 0 plus 16 power 1 into 2. Then you will get this answer. In the decimal format you will get. You will get answer in decimal format. Means when you write 2 into 16 power 1 plus 15 into 16 power 0, you will get answer in decimal format. You will get answer as 47. This you have to treat it as a decimal 47. And very important point here, in hexadecimal number systems, each digit represent 4 bits. In octal, each digit represents 3 bits, but in hexadecimal number system, each digit represents 4 bits. If you want to write, if you want to represent a hexadecimal number in your program, then how you can write 0x123. This is the meaning of hexadecimal 123. If you write 0x A25, then hexadecimal A25. If I write 0, 1, 2, 3, then this is octal 1, 2, 3. If I write directly 1, 2, 3, then this is decimal 1, 2, 3. If I write 0x 778899, then this is treated as hexadecimal 778899. Okay, and very important point I forgot here. Format specifier for hexadecimal. For hexadecimal number is percentage x. Percentage x is for hexadecimal number. And what is the format specifier for octal number system? Means percentage O. Percentage B for binary and percentage D for decimal. I hope clear. This table is important. This A means 10, B means 11. So you got some basic idea. But main important from this topic is how to convert from one number system to other number system. That we have to discuss. That is very important actually. This is just a theory concept, but we have to discuss now the calculations, how to convert from one number system to other number system. That we will discuss now. See here. So now number system conversions. First, before going to this, you should know how to write binary for a given number. That is very important. Okay, now I'm writing one number here, 72. Now tell me, this 72 belongs to decimal, octal, or hexadecimal? Tell me. I'm not mentioning anything, means by default it is decimal only. Now, what I'm expecting, write binary for 72. So this is the decimal number. How to write binary for decimal numbers? See here, if you want to write binary for decimal numbers, you have to follow this rule. Powers of 2. What are the powers of 2? 1, 2, 2 ka double, 4, 8, 4 का डबल 8, 8 का डबल 16, 16 का डबल 32, 32 का डबल 64, 128, 64 का डबल 128, 128 का डबल 256, like that you have to follow. So for which number you have to write binary? For 72. What is the nearest number in this series? What is the nearest number to 72? But it should be less than 72 or equal to 72, not greater than 72. So what is the nearest number? Nearest number is 64. So write 1 at nearest number, 64. So 72 nearest number is 64 in this series. So if you write 1 here, how much left in 72? Means you have 72 rupees. In 72 rupees you spent already 64 by writing 1 here. How much left? How much left means 8 left. So what is the nearest number to 8 in this series? What is the nearest number? 8 only. So simply write 1 here. And you spent 8 rupees. You have 8 rupees, you spent 8 rupees. Means, is there anything pending? No. So successfully completed your 72 binary. Then what about remaining numbers? Simply keep zeros. This is the binary for 72. In which format? For which number? 72. 72 decimal. So this is the decimal 72 in terms of binary. Getting my point? Similarly, we'll do one more example. Write 64 ka binary. Now tell me 64 is which number? Which number system? Decimal. How to write the binary for decimal? Follow this style. What is the style? You have to use 1, 2, 4, 8, 16, 32, 64, 128, like this. What is the nearest number to 64? 64 only directly. Is anything left? You spent 64 completely here. Nothing is left. So what about remaining numbers? Remaining numbers all are zeros. So this is the 64 ka binary. Which 64? Decimal 64. So if you want to write binary for decimal, you have to follow this series. Which series? Powers of 2. Powers of 2. So this is the style of decimal for writing binary. Style of decimal number in writing binary. Style in the sense, you have to follow powers of 2 to write the binary for decimal number. Okay. Similarly, what is the binary for 63? What is the binary for 63? This is decimal number. How to write the binary for 63 means how to write powers of 2. 1, 2, 4, 8, 16, 32, 64. Just double the number. 1 ka double 2, 2 ka double 4, 4 ka double 8, 8 ka double 16, 16 ka double 32, 32 ka double 64, and 128. But what is the nearest number to 63 now? 64. But 64 is greater than 63. It should be less than or equal to 63. So then tell me, what is the nearest number to 63? 32. How much left? In 63, you spent how much? 32. Then how much left? 31 left. 63 minus 32, which is 31. What is the nearest number to 31? Definitely 16. So write 1 here. Now In 31, how much done? 31 minus 16. How much? 15 left. So what is the nearest number to 15? 8. Then how much left? In 15, 8 is done. How much left? 7. So what is the nearest number to 7? 4. So in 7, 4 is done. How much left? 3. 3 is left. So what is the nearest number to 3? 2. So in 3, 2 is completed. How much left? 1. So what is the nearest number to 1? 1 itself. So done. 63 binary is done. Remaining all are zeros. So this is the binary for 63. Okay, na? And last and final, we'll take one more small example. Let's take 562. How to write binary for 562? Similar, same like 1, 2, 4, 8, 16, 32, 32, 64, 128, 256, 512. What is the nearest number? After 512, you may write 1024, but not necessary. This number is below 1024, right? So you can go with what is the nearest number to 562? 512. So in 562, you spent 512. Then how much left? In 562, you spent 512. How much left? 562 minus 512. How much left? 50 is left. So what is the nearest number to 50 in this series? 64 is also nearest number, but it is greater than 50. So what is the nearest number to 50 now? 32. So in 50, 32 done. 32 you spent. How much left? In 50, if you spend 32 rupees, how much left? 18 rupees. So what is the nearest number to 18? 16. In 18, you spend 16. How much left? 2 is left. So what is the nearest number to 2 here? 2 itself. So done. Everything is done. Okay. So now remaining all are zeros. I hope you clear how to write the binary for decimal number. These are the decimal numbers. So what is the style in writing the decimal binary for decimal number? Powers of 2. Remember this point. Every number system having its own style to write to represent the binary. So for decimal number system, the style is representing in powers of 2. Similarly, we'll write binary for take same numbers, but this time octal. So I'm going to write binary for octal 72. This is which number? Decimal or octal or hexadecimal? This is octal. If you write 0 before the number, then it is treated as octal number. Now how to write binary for octal number? You should not follow the powers of 2. Powers of 2 is followed for decimal number system. Then what is the style of octal? I already told this point. So in octal, each digit represents 3 bits. Getting my point? So in octal, each digit represents 3 bits. Now you have to write 7 binary in 3 bits format. How to write 7 binary in 3 bits format? 1, 1, 1. This is 7 binary in 3 bits format. Now write 2 binary in 3 bits format. 0, 1, 0. So this is the binary for octal 72. Getting my point? Similarly, how to write binary for octal 64? How to write binary for octal 64? Octal 64. How to write? So if it is octal number, then each digit represents 3 bits. Now, how to write 6 binary in 3 bits format? 1, 1, 0. 1 plus 2 plus 4. So 2 plus 4, 6. This is 6 binary in octal format. How to write 4 binary in 3 bits format? 1, 0, 0. So this is the binary for octal 64. Similarly, how to write binary for octal 63? So in octal, each digit represents 3 bits. So now 6 ka binary. I already written above 110 in 3 bits format, and 3 ka binary 011. Getting my point? And how to write binary for 562? How to write binary for 562? So 562 is which number here? Octal, hexadecimal or decimal? 562 is decimal because I didn't mention 0x or 0. If I mention 0x, then it is treated as hexadecimal. If I mention 0, then it is treated as octal. So now, how to write binary for octal 52? So if it is octal, then how to write the binary? What is the style of octal for representing its binary? Each digit represents 3 bits. So what we have to do now? Now write 2 binary in 3 bits format, like 0, 1, 0, next 6, 1, 1, 0, next 5, 1, 0, 1. So this is the binary for octal 562. Getting my point? Similarly, how to write binary for hexadecimal 72? How to write binary for hexadecimal 72? I already told you in hexadecimal each digit represent 4 bits, right? I already told you in hexadecimal each digit represents 4 bits. Then how to write hexadecimal binary now? So 2 in 4 bits format. 0, 0, just a minute. 0, 0, 1, 0, 7, 0, 1, 1, 1. So this is the binary for hexadecimal 72. If you want to write binary for hexadecimal, then each digit you have to write in 4 bits format. For a octal, how to write 3 bits format. For decimal, if you want to write binary for decimal, you have to write powers of 2 series. Okay, na? Similarly, how to write the binary for hexadecimal 64? Same, each digit represents 4 bits. So 6 means 0, 1, 1, 0. This is 6. How to write 4? 0, 1, 0, 0. This is the binary for hexadecimal 64. Similarly, how to write the binary for hexadecimal 63? How to write? Each digit represents 4 bits in hexadecimal. So 6 means 0, 1, 1, 0. 3 means 0, 0, 1, 1. How to write binary for 562? How to write binary for 562? 562. So each digit represents, this is 562 means you have to represent in hexadecimal. Now it is stated as hexadecimal 562. How to write binary? Each digit represents 4 bits. 1, 0, sorry, 0, 1, 0, 1, that is for 5, and 0, 1, 1, 0, that is for 6. Next 0, 0, 1, 0. This is the binary for 562 in hexadecimal format. But in hexadecimal, also A, B, C, D, E, F also coming. A means 10, B means 11, like that. What if the number is like that? So consider I'm writing the number as 0x 5D something like 2. So what is D? What is D? D means 13. I already told you that 10 means A, 11 means B, 12 means C, 13 means D. So D means 13. What is 13 ka binary? In 4 bits format, 1, 1, 0, 1. 1 plus 2 plus 4 plus 8. 8 plus 4, 12. 12 plus 1. Why you are not counting 0? If it is 0, you should not count. Okay. Only whenever you wrote once only, then only you have to count it. So this is the binary for D. So now how to write the binary for hexadecimal 5D2? 5 binary in 4 bits format. 0 1 0 1. D means 13. 13 binary, double 1 0 1 2 0 0 1 0. Getting my point? If it is like this, 0x2a. What is the binary for hexadecimal 2a? 2 means 0 0 1 0. A means 10. What is 10 binary in 4 bits format? 1 0 1 0. So this is the binary for hexadecimal 2a. I hope you clear with how to write binary for decimal, octal and hexadecimal. Getting my point? Now we'll discuss number conversions. Okay. Okay. First we'll take binary. Binary to remaining all like binary, binary to decimal, binary to octal and binary to hexadecimal. These number conversions are important for your GATE exam, especially for CSC and EC students. They will give simply one number, convert this from hexadecimal to decimal, decimal to hexadecimal, octal to hexadecimal, like that. They will ask. Okay. So first we'll convert from binary to decimal, binary to octal, next binary to hexadecimal. This is our target first. Consider there is a binary 0 0 1 1 0 0 1 1. Let's take this number. Okay. Then this is binary. Convert it into decimal. So I already told what is the decimal style. You have to follow the powers of 2 series. Getting my point? So the question is like this. Convert this binary to into decimal. This is the valid representation. Convert this binary to decimal. So how to convert this binary to decimal? What is the style of decimal in binary representation? Powers of 2. Just write as it is binary here. 1 0 0 1 1 0 0 1 1. This is the binary, given binary. Now how to do it? Powers of 2. 1 2 4, but don't write 4 here because it is 0. Next 8, don't write 8 here because it is 0. After 8, 16, you have to write 16 here. Next 32, next 64, don't write 64 because it is 0. Next 128, don't write 0 because it is 0. Sorry, don't write 128 because it is 0. 64, 128, this one 256. Now count this. Now count this. 256 plus 32 plus 16 plus 2 plus 1. So if you count this, you will get answer as 307. Getting my point? What if I convert same binary into other? Like now binary to same binary 1 0 0 1 1 0 0 1 1. Binary to I'm expecting into octal. Before converting, what is the style of octal? I already told for writing the binary. Each digit represents 3 bits. Then how to convert this into octal means just I'm writing same binary here 1 0 0 1 1 0 0 0 sorry 0 1 1. What is the style of octal? Each digit represents 3 bits. So you have to divide 3 bits, 3 bits, 3 bits and 3 bits. So what is the answer for these 3 bits? 0 1 1, which is 3. What is the answer for these 3 bits? 1, 1, 2, 4, which is 6. This one is 4, 1, 2, 4, 1, 2, 4, 6, and 3, 463. Getting my point? So what is the answer? This binary equivalent in octal is 463. In decimal, 307. But one more example I want to do here. There is some confusion here. What if the binary is like this? 1 1 0 0 1 1 0 0 1 1. This binary into octal. Then how to do it? Same, like you have to convert 3 bits. Like here only I'm converting 3 bits, 3 bits, and 3 bits. Here, whenever you convert, here one bit left. One is left here. So if one is left, simply add extra 2 zeros. Getting my point? If only one digit left, then you have to add extra remaining 2 zeros. If 2 bits left, then you have to add extra 1 0. That's it. So here 3, 6, 4, 1. 1463 is the answer. Getting my point? Yes or no? Similarly, I'm writing one more example here. How to convert this given binary 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. This is the binary and convert this binary into hexadecimal. How to convert? I already told what is the style of hexadecimal. In hexadecimal, each digit represent 4 bits. So just I am writing same binary here. 0, 1, 1, 0. Next 0, 1, 1, 0. Next 1, 0. Now convert 4 bits. 1, 2, 3, 4. Next 1, 2, 3, 4. Next, how many bits left? 2 bits. But in hexadecimal, each digit represents 4 bits. Then how many bits required? Extra 2 bits. Simply extra 2 bits will be zeros. Simply write zeros. Now calculate. What is 1010 means? 1010 means 1, 2, 4, 8, which is 10. 10 means you should not write 10. 10 means in hexadecimal, yay. Getting my point? Next, 1001 means 1, 2, 4, 8, which is 9. 0001, which is 1. So what is the answer? 19A. So this binary equivalent in hexadecimal is 19A. So now what happened here? We converted binary to decimal, binary to octal, and binary to hexadecimal. Now we'll convert decimal to binary, decimal to decimal to decimal to binary, decimal to octal, and decimal to hexadecimal. Okay, now each number we will focus. First we done with binary, next we'll take decimal, next we'll take octal, next we'll take hexadecimal, like that. Okay. But for this we required some more concept. Like I already told, what is the format specifier for decimal? %d. For octal, %o. For hexadecimal, %x. These format specifiers are important. Okay. Now what will focus? Decimal to other numbers. Okay. Now we'll discuss how to convert decimal to binary, decimal to octal, then decimal to hexadecimal. So what is decimal? All the numbers are decimal by default. Let's say 58 or let's say 57. This is which number? Decimal number. So first we have to convert this decimal number to, decimal number is base 10, to binary. Binary means base 2. How to convert? So binary, for writing the binary in decimal, what decimal follows? Which style it follows? Powers of 2. 1, 2, 4, 8, 16, 32, 64. What is the nearest number to 57? 32. How much left? In 57 you spent 32. How much left then? 57 minus 32, which is 25. What is the nearest number to 25? 16. So you spent 16 in 25. So 25 minus 16. How much left? 9. What is the nearest number to 9? 8. And how much left? In 9 you spent 8. How much left? 1 is left. So what is the nearest number to 1? 1 itself. So remaining all are zeros. So this is the conversion of decimal to binary. Then decimal to octal. Now confusion will come actually. Up to now easy, but now onwards confusions. So be careful. Now what is our second target? Our second target is like convert this 57 decimal to octal. So now tell me, this is, what is the meaning of this question? Can I say this question is decimal style to octal style? Getting my point? So what is the meaning of this decimal style to octal style? So what is the decimal style? This is actually in decimal style. Now you have to convert this decimal style to octal style. First, write the decimal style. Then convert that decimal style into octal style. What is the decimal style? I already told decimal style is powers of 2. Getting my point? Decimal style is powers of 2. So how to write 57 binary? Again, what I am telling, convert 57 decimal to octal, means decimal style to octal. What is the decimal style? Decimal style is 1, 2, 4, 8, 16, 32, 64. Nearest number is 32. And I already told about na, 32 plus 16 plus 8 plus 1. This is the decimal 57. This is the decimal style. Getting my point? So, okay, decimal style is ready. Now, decimal style into which style? Octal style. What is the style of octal? First, you have to write decimal style. Now, you have to convert that written decimal style into octal. What is octal style? Each dividing 3 bits. Octal style is each digit represents 3 bits. Now, what you have to write after writing decimal style? Now, convert it into octal style. Means simply you have to divide it 3 bits, 3 bits and 3 bits. Here only 1 bit left. So add remaining zeros. So this is treated as 0 only. No need to consider this. Now what is this 3 bits? 1, 2, 4. While you are calculating 3 bits, again you have to follow powers of 2 here. 1, 2, 4 like that. So 1, 2, 4 is 7. 0, 0, 0, 1, which is 71. Getting my point? Which is 71. Okay. So what I did here, decimal to octal. Sir, how to prove this? Decimal 10 is equal to octal 71. How to prove this? We'll do some programming here. What is the question I have taken? Decimal 57 in octal. Okay. See here. VA space prog1.c hash include stdio.h main function. Okay, so int x equal to 57 and printing. I'm converting this 57 into which one? Octal. What is the format specifier for octal? Percentage O. Percentage O slash n inverted commas close comma x. So now hexadecimal in octal. When you convert, decimal in octal. 57 is decimal, decimal to octal conversion. So simply you are telling print x is decimal, right? Print decimal 57 in octal format. So I already converted that. The output is 71. GCC space prog1.c dot slash a dot out. Getting my point? Yes or no? Now what we will do? Now same decimal to binary done, decimal to octal done. Now, now what we have to do? Just a second. Now decimal to hexadecimal. Same number only will take. 57. 57 decimal, convert it into hexadecimal. What is the decimal style? So what is the meaning of this question? Convert from decimal style to hexadecimal style. Why I'm using style and all? These are very confusing topics. That's why I'm teaching like this. But in interview point of view, you should not tell style and all. Okay? Just for understanding purpose, I'm using this terminology. You should not use this. So decimal style to hexadecimal style. So what is decimal style? It follows powers of 2, 1, 2, 4, 8, 16, 32, 64. So what is the nearest number to 57? 32. 32 plus 16, 48. 48 plus 8, 56. How much left? 1 left. So 1 itself. Remaining all are zeros. This is decimal style. Now you have to convert this style to hexadecimal. What is hexadecimal style? Each digit represents 4 bits. Simply divide 4 bits. So dividing 4 bits and dividing this 4 bits. So here only 3 bits is there. You can add zeros, no problem. So now this converted one is 1001, which is 9, and this one 1 plus 2, which is 3, 39. So decimal 57 is hexadecimal 39. How to prove this? Simply here you can print 57 in terms of hexadecimal in this program. See here. Simply printf printf decimal 57 in terms of what is the format specifier for hexadecimal? Percentage x. So print decimal 57 in hexadecimal. What is the answer? If you print a decimal 57 in hexadecimal, what is the answer? 39. Getting my point? So this last printf output is 39. GCC space prog1.c dot slash a dot out. See here, 39 is the output. Yes or no? Now what is pending? So binary to remaining all done, decimal to all other done. Now we'll take octal to remaining. Okay, see here. Next octal to binary and octal to decimal and octal to hexadecimal. Okay. Which number you will take? Let's take one example. 717. 717. This is octal. Convert this octal to binary. How to convert octal to binary? What is the octal style for writing the binary? Each digit represent 3 bits. So 7 means 3 bits. In 3-bit format, what is 7? 1, 1, 1. What is 1 in 3 bits format? 0, 0, 1. 7 means 1, 1, 1. So this is the octal to binary conversion. 717 octal number in terms of binary is this. Okay. Next, octal to decimal. Now second one, octal to decimal. 717 is in which format now? Octal format. Now convert to decimal. Which style to which style? Octal style to decimal style. What is the style of octal first? Each digit represents 3 bits. So this style to this style. So first write it in octal style. It is in octal style first. Next, octal style means each digit represents 3 bits. 0, 0, 1, 1, 1, 1. To which style? Decimal style. So what is the decimal style? You have to follow powers of 2. Decimal style is that only. So now just I'm writing same here. 1, 1, 1, 0, 0, 1, 1, 1, 1. Powers of 2 means 1, 2, 4, 8, 16, 32, 64, 128, 256. Wherever you wrote ones, then you have to write the numbers. If zeros, you can ignore. So 1, 2, 4, 8, 16 is ignored. 32 is ignored. Then 64, 128, 256. So octal style to decimal style. This is. What is the answer? What is the answer? Answer is 256 plus 128 plus 64 plus 8 plus 4 plus 2 plus 1. 8 plus 4 plus 2 plus 1. What is the answer? 463. Answer is 463. Getting my point? Next, this one is octal to binary, octal to decimal. So octal to binary done, octal to decimal done. Now octal to hexadecimal. Consider 717 is a octal number and you have to convert this into hexadecimal. Means what is the question meaning here? Octal style to hexadecimal style. What is the octal style? Dividing each digit in 3-bit format. What is hexadecimal style? Dividing each digit as a 4-bit format. But you have to write first octal style. Octal style into hexadecimal style. So octal style is 7 means 111, 1 means 001, 7 means 111. Now you have to convert this into what? Hexadecimal. So what is hexadecimal style? Divide this into 4 bits. So simply divide 4 bits and 4 bits and here only one bit left. Add remaining 3 bits as zeros. So now calculate this. 4 ones. 1, 2, 3, 4. 4 ones means 1, 2, 4, 8. Means 1, 2, 4, 8 means 15. Getting my point? 1, 2, 4, 8 means 15. What is 15 means? 15 means what in hexadecimal? A means 10, B 11, C 12, D 13, E 14, F 15. So this is F. F double 1 double 0. 1, 2, 4, 8. 4 plus 8, which is 12. 12 means C. Answer is 1 CF. 0001 means 1. 1 CF is the answer. So octal 717 in terms of decimal is 463. And in terms of hexadecimal is 1 CF. We'll see this. So you have to give the 717 octal input and print this. Just a second. Okay. Now see here. Vi space prog2.c. Write hash include stdio.h into main function. And which is the input I'm taking? Let's take int some variable, any variable you can take. Int z equal to, what is the input you have taken? What is the input here? 717 octal. So 717 octal number in decimal is 463. 717 octal in hexadecimal is 1 CF. Remember this. 717 octal. Octal means you have to write 0. Int z equal to octal 717. This is the octal meaning. You have to, if you want to represent it as a octal, then you have to write 0. Then only the system will understand, okay, 717 is a octal number. Now you are printing this printf percentage O. Consider percentage in terms of percentage O I am printing. Percentage O is for octal only. If you print Z in a percentage O format, what is the octal number of 717? 717 itself. So Z will be printed as 717 only. Now I am printing same Z YYPP. Now I am printing same Z in terms of decimal. I already converted previously. What is the decimal value? 463. See here. 463. And hexadecimal is 1 CF. So now if I print in percentage D format means decimal format, percentage D means decimal. So if I print in decimal format, 463 will be printed. If I print percentage X means hexadecimal format, 1 CF will be printed. See here. So 463 and this last one is hexadecimal, which is 1 CF. So this is percentage X. Simply cc space prog2.c /a.out. See here, 717, 463, 1 CF. 717 is octal format, 463 is decimal format, 1CF is hexadecimal format. Getting my point? Okay. Next, what is left? Decimal done, octal done. Now, last and final, hexadecimal. Okay, fine. Now, we'll see here hexadecimal to remaining all conversions. Hexadecimal. Hexadecimal to binary. Hexadecimal to octal. Hexadecimal to decimal. So similarly, so first let's take number as 432 to the base 16 to convert into binary format. So what is the style of hexadecimal for writing binary? Dividing each digit as 4 bits. So how to do it? Answer is 0 1 0 0 and 3 is 0 0 1 1 and 2 is 0 0 1 0. This is the answer. Next, hexadecimal to octal. How to do it? Hexadecimal to octal. So 432 is in hexadecimal. Now convert it into octal style. Octal means base 8. How to convert this? First write hexadecimal style, then convert that style into octal style. So 432 hexadecimal style is, I already wrote 0 1 0 0. Next 0 0 1 1. 2 means 0 0 1 0. Now divide it into convert it into octal means 3 bits division. 3 bits, 3 bits, 3 bits and 3 bits. Perfect. Now 0 1 0 means 0 1 0 means whenever you are calculating, again you have to calculate in powers of 2. After division, don't confuse. Now you have to calculate the answer in powers of 2 only. 1 2. So this is 2. 0 0 0 which is 0 only. Double 1 0 1 2 4 which is 6. Getting my point? Next 2 0 6 0 1 0 which is 2. 20 62. Getting my point? Next hexadecimal to decimal. So which style to which style? 432 is in hexadecimal. Now convert this into decimal style. Decimal style means base 10. Now tell me what is the style of hexadecimal? Dividing 4 bits. This style to this style. What is the style of 10? Sorry, base, what is the style of decimal? Powers of 2. So first write this style and convert this style to this style. What is this style first? This style is 4 means 0 1 0 0. 3 means 0 0 1 1. 2 means 0 0 1 0. Now this is hexadecimal style. Now convert this into decimal style. What is the decimal style? You have to count each and every digit. Follow the series of powers of 2. 1 2 4 8 16 32 64 128 256 512. After that 1024 2048. 2048 is 0. No need to count this. So this is the answer. So what is the answer? 1024 plus 32 plus 16 plus 2. What is the answer? 1074 is the answer. So hexadecimal 432 in decimal is 1074 is the answer. Okay, na? Okay, see now. So hexadecimal 432 I'm taking as an example. Okay, I hope you clear. This application is not working now as of now, but it is same as previous. Like what I'm going to do here, simply I'm writing the program here like int main function, and I'm taking hexadecimal value int some x equal to 0x 432 means it is hexadecimal 432, and after that I'm printing printf percentage x comma x. What is x? 432. 432 in terms of hexadecimal, 432 only. And if I print printf percentage d comma x, what is x? 432. 432 in hexadecimal. If you print x, which is hexadecimal in terms of decimal, what is the output printed? See here, decimal format, which is 1074. This answer is 1074. And if I print printf percentage o comma inverted commas close comma x, if I print this, what it is going to print? X is a hexadecimal 432 in terms of octal. Percentage o means octal. When you convert hexadecimal to octal, what is the answer you got here? See here, 2062 is the answer. So you will get answer as, for this, 2062. Getting my point? Because there is some issue with this application, that's why I'm explaining like this. I hope you clear with all conversions. Okay, thank you.